Okay, could we get started, everyone? Okay, so we're going to have, actually, I've got some extra chocolates and bars here. That's my contribution today. If it's left over, by the way, at least anyone's here, take these and bring them over in the student room next door. Okay, so I do want to introduce Ali because I'm so delighted he's come here. So he's, as you can see here, he's a professor at Fresno State. He started up a transportation institute there, runs a big conference every year. He just started it a few years ago. And I kind of relate because I started up ITS many years ago, and so Ali's trying to do the same thing at Fresno. So he just a little background is he grew up. He's going to tell you a little bit more about himself. I encourage it, but he grew up in Northern Africa, Middle East, Europe. Got his PhD at Virginia Tech, and those of you who are into some of the data. Virginia Tech had this massive naturalistic, they called it naturalistic data set of all this data on people's driving behavior and crashes and so on, and so it was really extraordinary. And you use that data for, Ali used it for his PhD dissertation. So, we just had a lively discussion here already because, as we start thinking about behavior, it affects everything that we're all working on. And so Ali's, this is what he's been working on, and he's making lots of contributions. So I'm really pleased. And so he's not so far away from us. So I think, maybe there'll be some good interactions, collaborations we can have in the future. So Young-Sung is going to take over. He's going to be moderating it. I've got to take off. But thank you so much for coming. It's a great pleasure to have you here.
Thank you so much for inviting me. I'm sure you all know that Professor Dan is a world-renowned figure. So I think first time I met him was at TRB. I think that was maybe 14 years ago. But at that time I was still a graduate student. I was very young, so he may have not noticed me.
And I was already very old.
At that time, but he's always someone that you can always learn a lot from him. You're all lucky that you're working in a team with him. I always encourage you to try pick all kinds of random conversations with him because you're going to benefit a lot. So the people in our world who are as generous as he is are not so many. So I always encourage you to take advantage of his knowledge and his generosity.
You can see what a gracious person he is.
Thank you.
Thank you.
All right, so thank you all for having me and for being here today. So as Dan said, my name is Ali Tawfik, and they asked me to share a little bit about my journey until I came until today with you. So I was born in Egypt almost 50 years ago, but I grew up in many parts of the world. So my dad has his own business. He was a computer scientist, but at this time, computers were not as small as this. They were as big as this whole building. So they were called mainframes. So he was a mainframe programmer. And then when PCs were invented, he started introducing the world to what a PC is. So nobody knew what it is. So all his clients were either countries or cities. So it was always, his new contract would be with the country, state of Singapore. So we would travel there and spend 1 year until he builds the PC system for them, trains them what a PC is, creates the software for them. But at that time, there were no softwares, there were no Windows, nothing. So every few years, we would move to a different country or a different city just because that's what his contract would be. But then in high school, I went back to Egypt. So I did my high school in Egypt, and I did my undergraduate degree from Cairo University in Egypt. And I worked there at a center that was created by the MIT at the university 50 years ago. It was 20 years before I joined them, and I worked there for 5 years. And during these 5 years, I worked on many projects with the European Union, many projects with the Southern Europe countries called Euromed, so the Mediterranean countries, the integration of their transportation systems and policies and so on. And then obviously lots of projects in Cairo, and then some of our touristic resorts on the Red Sea. I do not know how much you know about Egypt, but we have one of the best free diving places in the whole world on the Red Sea. So Sharm el-Sheikh is a world famous city for as a touristic destination. And then Dahab is called the, so that's another city on the Red Sea, it's called the windsurfing capital of the world. So we have lots of tourists traveling all the time to these destinations year round, and we designed some of the public transportation systems for them in these two cities back when I was working there. And then I moved to Virginia Tech for my graduate studies. And after Virginia Tech, I came to Fresno State, where I have been a professor now for 11 years. So this is a quick background about who I am. And perhaps I can start discussing. 5 years ago, we created the Fresno State Transportation Institute. I do not know how much you know about Central California. Are you part of Central California? Davis?
No, I don't think so.
Sacramento
Central
is-
Valley. So your reason is about Central Valley.
Central Valley.
Yeah, this is more like Sacramento metro area.
So
really
Sacramento, so Central Valley is two valleys. The north half of the Central Valley is the Sacramento Valley, and the southern half is San Joaquin Valley. Both of them make the Central Valley.
Oh, then they're considered part of that valley, right?
Yes, I think so. The San Joaquin, well, most of the Central Valley, but primarily the San Joaquin Valley is very different from the rest of California. So for one, they're very Republican, very red. The city, Fresno City itself is blue, but the valley in general, all around Fresno City is highly red. So, but the guns are very popular over there. Trucks are extremely popular over there, and cowboys, actually Clovis, which is part of Fresno Metro, is called the city of cowboys, or the cowboy city. So we have a very big rodeo, like attracts lots of. So Central California, Central Valley is very different from the rest of California. And their views and visions are also very different. So there's huge parts of the population are disadvantaged. Agriculture is the main industry. But also we have lots of ranches and dairy products and so on, and that's part of the reason why it is conservative, I believe. But there's lots of need of education. Education is a very significant instrument that we believe, as my university, Fresno State. Part of the reason I've never tried to leave Fresno State is because you get a huge level of satisfaction when the people that you're serving, when your services make that much of a difference for them. When I was in my graduate school at Virginia Tech, so we had a certificate that was developed by the dean of our graduate studies. Her name is Karen DePaul. She's a great lady. And she developed a degree that's called Preparing the Future Professoriate. So in addition to my PhD, which is 90 units, I did 30 units on this Preparing the Future Professoriate. And we had lots of time, so I took 10 courses that had nothing to do with engineering. And it was all about the theory of higher education. What's the purpose of higher education? Why do we do whatever we do? Why did we create universities? What is the role? What was the past role of universities? What's the current role? What's the future role? What are the different types of universities? So R1 versus liberal arts colleges. And actually, after I graduated from there, naturally, most of us in R1 universities, our dream is to, once we finish, we want to do the same thing that we saw our professors do. We want to be very active in research. We want to join an R1 university. But then in that's all I wanted as well. Until one of the courses that I took with the Dean of Graduate Studies back then, and I learned about the different types of universities in the US. I learned what's an R1, what's an R2, what's the mission of that, what's the mission of a liberal arts college, how different are they in design, what kind of different services they provide. And I got very interested, and I decided after I finished, I'm going to try a liberal arts college before I make my choice. And I taught for 1 year. I was a visiting professor for 1 year at a private liberal arts college called Lafayette College in Pennsylvania. And I was extremely impressed by the difference. So having the freedom to research whatever you want to research, not being driven by the research dollars, having the freedom to publish at a much less intensity, whenever you're publishing a paper, you're enjoying your time doing it yourself, having the added benefit of being more engaged with your students because you don't have all these 20 different projects that you're working on at the same time. So I was very attracted to this model. I found out, and also collaborations. I love collaborations, working with others, especially for non-engineers, because I learn a lot from their differences of their views. And this liberal arts college engineering is not the big part of the school. So I benefited a lot from this experience. And when I got the offer from Fresno State, I accepted, and I never tried to leave since then. Although many of my many of my peers and people I work on different committees, they're always trying to attract me to move to their universities. But I feel a significant amount of self-satisfaction and proud in my work and how it affects the lives of the community that I haven't even, not once did I entertain the thought of leaving. Now, as part of this, so 5 years ago, and this is again, this is a testament about how Fresno is very different than whatever the reputation it has is. So 5 years ago, we did not have a transportation institute at Fresno. So we approached the local MPO and the local cities, and we said, we think we can do better in transportation. We think the way our city is running, which is primarily designed for the car and nothing else, and the views of the people who are very conservative in terms of taxing and in terms of spending and what should we study and how we should design or envision our region in the future. So we went to the MPO, the local engineers and planners, and we said we think we can do better. We would like to start a transportation institute with these 4 main missions: education, research, technical service, and outreach. And we did, I think I did like maybe 18 different presentations to 18 different groups, and all of them stood firmly in support of this idea. At the end, our institute was funded for 5 years by our local transportation taxes. So it was not funded by the state, it was not funded by the federal government. So it was funded by the constituents within our Fresno County. So they decided, yes, we can do better and we should do better, and science and education are extremely important, and they gave us $3 million to start our institute to fund our institute for 5 years. Interestingly, in the same year, we pursued a state grant to become a California state part of the California State University Transportation Consortium, and we were awarded. So there are 23 CSUs, 4 of us, which is San Jose, Long Beach, Chico, and Fresno. We form the California State University Transportation Consortium. And we have been part of this consortium for since the same year, 2018. So 6 years now. All right, so now feel free to interrupt me at any point in time. If you have any comments or questions, just raise your hand. And please start by stating your name so that I can try to, if I need to refer to something that you said later on, then I know who to refer to. And I love conversations, I love collaborative work, so this is something that I enjoy. So feel free to interrupt me and share comments or viewpoints or ideas or questions at any point in time. Yes.
Dr. Tawfik.
Yes, sir.
My name is Timothy. I'm a master's student here, and I just wanted to ask you immediately. So you came into this presentation talking about the 30 extra units you took during your PhD, focused on with the theory of professorship, and then also your year spent at Lafayette College, working in a liberal arts institution. To what extent then have you taken these lessons you've learned and implemented them at Fresno State's Transportation Institute? And how does the Institute, what is their ideology? How is it a little bit different than maybe a larger state schools? And then I also imagine with the same background you had, that's why you took that when you asked for the local municipality and MPO and such to fund your institution, this kind of public service, really focusing on outreach and education to the general public. That's why you focused on that. So maybe have that in 1 minute. Sorry, Doctor.
Yeah, Tim, thank you for a very good question. And for the sake of time, we have 28 attendees online. So I guess please address the question in a very effective ways and start the research talk.
Okay. So I think that's a great question. So thank you, Timothy. So part of our preparing future professoriate graduate certificate was civic engagement and was citizen scholar. So what is a citizen scholar? What's our responsibility as scholars towards the public? And as part of this citizen scholar, actually it was a certificate of its own. So you have to, if you were to do a civic engagement public service project, you actually get an additional survey called the citizen scholar certificate. And that, so what we learned, or at least what I was sold on, what the idea that I liked is science is created to serve our community. That I don't, that if science is just theoretical and it doesn't serve a purpose, then it's not as valuable to the community. And because of that, so in my philosophy, either as directing the institute or when we came to the county, or in my research, is always trying to find ideas or projects that have a very direct relationship with our constituents. So what can I do that would be good additional knowledge, but at the same time have implicable impact on the way we do things? And that was one of the ways of how we solved, or how our constituents agreed that the transmission suite would be valuable. It's because we said these are kinds of projects that we think we could serve our community, and they agreed. And this project is one of them. So when I did this project and I presented to the community, everybody started saying, well, we should think more about this. Our channel band models, we should update them, because whatever we're going to envision is going to happen the way we're designing our city may not be true, because telecommuting is going to affect this. So we need to change the way we're doing things. Now, I'm not talking about scientists, I'm talking about practitioners, so that we can design and plan our city in a more efficient way. All right, so this project, or this presentation, is based on two different studies. One study is a research by a master's student, one of my master's students who works in Caltrans now. And the other part is a federal project, a federal funded project. And the two projects have two different objectives. But the question that we're trying to answer is, how is telecommuting going to affect our future? And I'll stop here and ask you, how do you think telecommuting is going to affect our future?
Less VMT.
Right, less VMT. What else? And your name?
Terra.
Terra. All right, so Terra and Timothy. They both agreed, so yes, less VMT. You, yes?
We might do more like shopping trips, like because they're not having Uber.
All right, so maybe they're going to do more shopping trips, and maybe this additional shopping trips are going to take away some of the benefits of not going to work. Great point. Yes?
More time with the family or at the gym.
Right, more time with the family at the gym. Excellent. So, so the question that we're trying to answer is about VMT. So the question, because VMT is related to emissions and energy and congestion, so VMT is related to everything. So if telecommute, which most people intuitively believe that it's going to reduce VMT, and is that true, and by how much? And this is the objective of both of these studies. So we started by, Patrick's work, so I'll start by acknowledging my colleagues who did this work. So Patrick is my master's student, so he worked on the first project that I'm going to present for his master's thesis. And then the second federal project, I worked with the FHWA as well as Deloitte. So Heather Rose is the project leader at the FHWA, Office of Transportation Policy Studies. And then my 5 partners down here are from Deloitte. So Adnan and Sani and Matt and Zach and Helena. So these are my colleagues who are working on our second project. And in my presentation, I'll present both projects and our findings. So the first project is an analysis of telecommuting travel behavior in the USA. So that's Patrick's project. And we used the National Household Travel Survey for his analysis. And then the second project is the FHWA's Mobility Trends and Future Demand Study. And in this one, we did not use the NHTS. We used data from the year 2000 till 2020. So we used different data sets instead of just depending on the stated household travel survey, preference survey. So I'll start with the first project. So Patrick's project using the NHTS data, as I'll have some introduction background, what's the objectives of the study, what's the data set that we use, what's the methodology, what our results and conclusions are. So, so the motivation of Patrick's work is, so he was starting his master's while the COVID was happening. So he got very interested, how is telework affecting our cities? People are working from home, there's no congestion. Suddenly Los Angeles people can see the mountains. He discovered that Los Angeles does by the mountains. So there are wild animals on the streets. So he was very impressed with all of this. I said, is telecommuting going to be really the solution of the future? If people work from home, is our lives going to change? This was his motivation. So he wanted to investigate the effect of telecommuting on trip counts. So how often do people make trips per day? What's their commute time? What's their travel trip miles? And what are the characteristics of telecommuters? Is there a specific age? Is there a specific job category or education level? And is there a specific household income? So we used the NHS 2017 data set, and we used 6 fields, 6 attributes from the data set. Is the person a worker? Where do they work from? Do they typically work from home or the office? How many times they worked from home in the previous months? Do they have the option to work at home? During this specific travel day where he answered the household travel survey, were they working at home or at the office? And what is the trip purpose of their home-based trips? So this is we classified teleworkers into 5 classes. So the first class is people home-based. Trying to find the laser. Okay, so the first one, do they work home-based? Means they are like freelancers, where they're always working from home. They don't actually have an office. So we asked them the question: Are you? And all of these are workers. So we limited our study only to people who actually have work. And if they have work, we asked them: So do you work from home or from office? If they say I always work from home, then they're a home-based worker. They don't even have an office. And then if they said no, I do not work at home, then you say, okay, so in the past 50, do you have the option to work at home? And if the answer is yes, then they are a teleworker. And then we ask them, how many trips have you done in the past 30 days? How many days have you worked from home? And it was in the past 30 days, have you worked from home? If the answer is yes, is no, home-based work trips reported. If the answer is no, then we call them, so they are primary teleworker, so they work primarily from home. If the answer is yes, then they're ancillary teleworker. So it depends on the past 30 days. Have they worked from home? Yes, they're a primary teleworker. No, then they are an ancillary teleworker. And then if no, they haven't worked from home any days in the past 30 days, then we ask them, does your work allow you the option of working from home? If the answer is yes, my work allows me this option, but I do not, then we call them a passive telecommuter. And no, my work does not allow me, then they are a non-telecommuter. So we classify them home-based, that's the person, or let's start with none. So non-telecommuter, that's the person who only works from the office and is not allowed to work anywhere except from the office. That's a non-telecommuter. Second, the person who works from the office but has the option, the work allows them to work from home, but they decide not to, so we call them passive telecommuter. So we have the option, but they do not. And then people who telework a lot, we call them primary telecommuters. People who telecommute a little, we call them ancillary telecommuters. And last, people who do not have an office, they work only from home, we call them home-based workers. So 5 classes of telework. So the question now, these different type classes, what is their travel activity? How often do they make trips? How far do they travel? And when do they travel? So is working from home going to solve some of our transportation questions? So we started by understanding what is the population of these different subgroups. So people who have no option except to work from home, to work from the office, non-teleworkers, are the majority of the population. In urban America, there's about 72% of the population. They work only from the office. They have no option except to work only from the office. And 75% in rural, they have no option except to work from the office. So now these are all the farmers, the mechanics. These are all the jobs that they cannot do their work except from the office. And then passive teleworkers, so these who have the option to work from home but they don't, is about 2.5%, 4%. Ancillary teleworkers, so those who work from home sometimes, is 5%. Primary teleworkers, 3%. And passive, so those who have the option to work from home but they don't, is 15%. So this is the group. So we know that about 1/4 of the population has the option, sometimes works from home. This is our sample size. All right, so how long does it take you to average time to work? If you were to commute to work, how long would it take you? Non-teleworkers is the least amount. So people who work from the office, it takes them on average in urban and rural America between 25 to 26 minutes. As telework increases, so passive takes them longer, ancillary takes them longer, primary takes them the longest, home-based, so those who have no option except to work from their home, so they do not commute to work, so they have 0. So what does this figure tell you? So the more you telework, the longer you commute. What information would we deduce from this?
Further away.
Right, so one possible explanation is that, well, we know that the more you commute, the further away you live. So the question now is it because you telecommute, so you choose to live further, or is it because your commute is longer, then you would rather work from home some more time? So which direction of the relationship, which is causing which, it's probably a two-way relationship, but our conclusion is, we know very well, people who telecommute more, their commute trip is longer, whether it's urban or rural America. So that's the first thing that we learned. So we said, okay, so how often, or what is their trip rates? How many trips do they make per day? So in urban America, we have non-telecommuters, so those who work from office, they make about less than 4 trips per day. But the more they telecommute, so passive, then ancillary, the primary, the more trips they make per day. Now, if they're working from home, if they have no office, they still make a little bit more than non-telecommuter, but marginally. All right, so this was our first shock. Why is this a shock? What does this figure tell you? Now, you'll see that the work trip, which is home-based work, the yellow trip, is increasing. But except for the primary telecommuter, so they work a lot from home, they don't have home-based work trips. So what do we deduce from this?
Well, what they were saying, that you're doing other trips.
Exactly. So your comment is actually what's happening. So while the work trips are getting less, you're actually doing more trips per day. So you're doing, so the classification, the class of home-based other, so this increased significantly. Your orange, home-based shopping, this increased. Non-home-based increased significantly. So while your home-based work trips are reducing, all your other trips rates are going up. And at the end, you end up making more trips per day than if you were working from the office. Now, does this make sense? Now, whenever you're working with data, you always have to ask yourself, is this data true? Because there's no such data that does not have inherent inconsistencies and errors. So the first thing you ask yourself, does this make sense? Yes?
Do you know the distance of the other trips?
All right, so and that's going to be the next slide. So that's the question. Now, before we go to the next slide, does this make sense? If you see yourself or your friends, or if you think logically, the person working from home, would they make more or less trips per day?
It's the same.
So if you're at work versus if you're at home.
More trips if you're at home, shorter trips probably.
Exactly, so more trips if you're home because I have my 8 hours, I'm much more free. I can run to the grocery shop or to the supermarket or to go pick my kids from somewhere and come back before anybody at work notices. Or I can go pick my laundry, or I can go grab an ice cream, or I can go to the gym for half an hour, but if I'm at work, I don't have my gym clothes, but at home I have my gym clothes, so I can easily change, go to the gym and come back. Or I can go for a quick walk with my dog. If I'm at my office, I can't do that, but if I'm home, I can certainly do that. I'll quickly grab my dog, go for 10 minutes and come back. So it makes sense that the more you work from home, the more trips you're going to make per day. So the question now becomes, right, so perhaps, now this was the first shock because we thought that people would make less trips per day because the work trip is gone. We discovered, no, that's not the case. So we thought, okay, that makes sense. Yeah, we would not think this really through. It makes sense that if we're working from home, that we make more trips. But I think these trips would be shorter because it's shorter trips. Run to the grocery store, walk my dog, So I think the number of miles we're going to save, so teleworkers are going to be driving less miles per day. So I mean, that makes sense. All right, so we went to the next one. Daily trip miles. So do teleworkers drive less miles per day? What do you see?
Yes.
All right, so this is the number of miles, and this is how much teleworking. So teleworking increasing, what happens to the miles per day?
That's not
Increasing. So,
home-based.
well, home-based is still higher than non-home-based, but it's still, so non-home-based is a little different. So freelancers are a little different, but there's still more than people who work from the office. So now we said, okay, so what's happening now? So we thought that telework is going to help us, but they're going to make less trips per day, but we discovered we're wrong. So we thought, oh, perhaps these trips are shorter, they're going to be driving less miles per day. But again, we're wrong. Now, why are we wrong this time?
Computer nomads, they're going to the beach to work now. Going back to their parents. For 3 days to the day.
So that's what we thought. We thought a lot of people who work from home, they fly more. So because we can take these quick vacations, I can work from anywhere. I don't have to work from Fresno, I can work from the beach or from Europe. So perhaps this increase in miles is because of my transportation mode. Perhaps there's lots of air trips, and if we take them out, then we'll see that telecommuters drive less per day. So we started looking at mode split. So this is the mode split of the car, and SUV, and van, and pickup, and motorcycles, and taxi, and this is air travel. And we see, yes, telecommuters are flying a lot more. And the more you telecommute, the higher your airplane miles. Okay, that makes sense. So if we take away air travel, then VMT should, or miles per day, should see decreasing. So we said, okay, let's take away air travel. Now this is urban and this is rural, and most of the time we see that they're very similar. So we took away air miles and we said, okay, so let's see what's happening now. So this is non-teleworkers, non-telecommuters, this is passive, this is ancillary, this is primary. What's happening? They're still increasing.
Wow.
So they're not increasing as much as they were before, but they're still increasing. So teleworkers are making more trips and more miles per day.
Are they happy?
Are they happy? We didn't check. So NHS doesn't ask about this, but it's a good thing to check. But we said, okay, so perhaps there's still hope. There's still hope that telework is going to change or improve the status quo. Can you tell me where would we get such hope? What thing that if we investigate, then maybe these extra miles are not so bad?
Percentage of miles in car.
Oh, the mode.
So the mode we already investigated.
Yeah.
So that's the mode.
But, and this is in private vehicles.
Yes, this is only private vehicles.
Maybe like a diversification of destinations. Like for example, if everybody just goes to the working district to work, and then just also like congestion around, but then people go shopping and
Exactly.
Like kids, they go to different destinations, so it doesn't get congested in a single area.
Exactly. Now we didn't investigate areas because NHS doesn't give you the geotag, but we thought perhaps these teleworkers are smart. So the traffic congestion is happening in the morning, so they make their trips when it's not traffic congested. So we thought, yeah, maybe if maybe this teleworker is spreading the congestion, which would be a good thing. So we're reducing congestion. So we said, okay, let's see one of these trips happen. So we plotted the figures. So the red one is the normal people, and then the yellow one is people telecommuting. So red is normal, yellow is telecommuting, and gray is urban passive, and then blue is urban primary. So the blue and the yellow are the people who are telecommuting. So we discovered, yes, there is a tiny shift in when the trips are happening, but they're still happening during the peak hour, whether in the morning or in the evening. So yes.
Since you're letting us guess, does having children affect this? Like school times have to be fixed?
So exactly. So I thought, okay, well, this is not again what we expected. We expected that these people are gonna help us in some way or the other, make less trips, drive less, drive off peak. But every time we investigated something, no, they're not helping us in any way. So we said, okay, perhaps they're driving during the peak hour, but they're driving shorter distances. So maybe they're just going to the school, dropping the kids and coming back. So maybe they're driving less distances, which means they're self-helping relieve some congestion. So they're doing the shorter trips during the peak hour and longer trips during off-peak. So they said, okay, let's see how many miles are they driving during every hour of the day and how this relates to normal people. Well, by normal people, I mean non-telecommuters. So this is the travel miles by private vehicle. So this is how far are they traveling during the different hours of the day. And then you will see that the red, which is the normal, and the yellow are around the same, but the blue is even higher. So they're traveling further away during peak hour.
Going from they're going somewhere further away with it.
They are going for something further away. Now at this time, Patrick was about to graduate, so we had to wrap up his research. So we stopped asking questions after this. He said, I mean, there's no hope in these telecommuters. Patrick, go live your life, find a job, start earning money, and don't worry about telecommuters. They're not going to help us anymore.
Become a telecommuter.
But one last thing before you go, let's try to find these telecommuters, who they are, so that we can start having a closer look at who they are later on. So let's find out what their gender, what their age, what their income, so we can start investigating them sometime later. So we did the same thing with time, not just distance. How far are they traveling? We said, okay, maybe they're traveling further, but maybe they're traveling in less congested routes, they're spending less time. Turns out they're still spending the less time during the peak hours. So we started looking at age classification. So who are these telecommuters? What's their age level? And we discovered that as telecommuting increases, so the age level increases, except for the passive teleworkers. They are slightly younger population, older population. And we looked at this telecommuting. So the top one are not normal people. The yellow is passive. The green is ancillary, primary, and home-based. And we find that as going from ancillary are younger generations, so the frequency, so the X bar is your age, and this is a density plot. So the higher the bar means there's more people from this age group, and this, so you'll see that this is the normal, so most people in the workforce are older or younger, and in the middle they have less fortune working. But this density plot shifts a little bit to the right with ancillary, so with passive teleworkers. So people who have the option to telework and they choose not to are older generations, which makes sense. So the people who live their whole life working from the office and they're happy and satisfied working from the office. People who telework less, now this curve shifts to the left. So they're younger people, they telework a little bit at the time. But people who telework most of their time, they are the younger generations. People who are freelancers, they work primarily from home, they have no office, are older generations. So these are people who are probably retired and they're doing some consulting work.
Were the working hours during which you count the miles same for all the observations in the data set? Or for some cases, I think of telecommuting, it's useful because you can work at hours, especially in the pandemic where different time zones are concerned. You can work late at night, so were the working hours generally more or less the same across the data set when you count those miles?
Yes, so yes, but within their own zones. So in the National Household Travel Survey, when you ask someone, when did you leave? They say, in my time I left at 8 a.m.
Okay.
So it's all within the same model.
Okay.
We started looking at education. So what's the level of education of teleworkers? So people who do not telework, their level of education. So this is basic education. So up here is the graduate, and then down here is the bachelor's, and then green is some college. So you start with little education, and as your education increases, you go up, and this is the frequency split. So non-teleworkers, most of them have lower levels of education, less graduate levels. As the graduate education increases, the percentage of teleworking increases, which says that white-collar jobs are more likely to telecommute than blue-collar jobs, which makes sense. So whether it's in urban America or rural America. On this side, we started looking at job classifications. So sales people or manufacturing people and so on, and everything seemed to follow our expectations. Last is income. So teleworkers, what's their level of income? And people who telework have a higher income, which again is expected. So the more white collar job you have the luxury of earning more and working from home. So that all falls within our expectations. So Patrick's conclusion at the end was telecommuters made more trips and traveled longer distances. They have the option of telecommuting was shown to increase trip counts and trip miles by both airplane and private automobile. So the impact on VMT and air pollution and energy and emissions and all that, they don't really help. So telecommuters have a higher impact on our transportation systems. Telecommuting is generally correlated, so the higher the education, the more white-collar the job is, the greater the household income, the more likely that people are telecommute, the more likely that we're going to have more VMT and more emissions and energy and all of that. So as time progresses and everything starts becoming more computerized, then we expect that we're going to have more VMT and everything else associated with increased VMT. So this is Patrick's conclusion at the end. I'm going to come back and revisit this at the end. Now, this is the end of Patrick's study and the beginning of the federal highway study. Yes?
Can you please remind us the time frame of the data and NHTS 2017 or 2020?
2017.
17.
Yes.
Did you have a chance to check the stats with the new NHTS that was published in?
Not yet. So we're planning to, but not yet. So Patrick was already working now, so he's not interested in doing research.
Okay.
So someone else. Yes.
Go ahead, sorry.
Yes.
I may have missed this, but do you have a slide on what was the VMT for the air travel trips for the primary tele workers? Or they're traveling, let's say, by airplane to nearby destinations, and maybe the VMT is less compared to.
Yeah, so this is the miles. So how many miles they're traveling.
Yeah.
And the airplane is 21 miles per person per day.
Okay.
Yes.
Would you ask about your density graph on the normal or the usual people going into the office, the red, the density plot, it makes a dip, like at a certain age right there.
Yes.
It's different from urban to rural, but do you have a inference in why that happens at 45 to 50, or I don't know, 55 to 45?
No, we did not look at that. But I think if we add all of these together, it's not gonna look as skewed. If we have the whole population, we think just some people in specific groups, they are more situated to work from home or to work from office or.
That's thinking. This is the red people are going to the office. It may be gender, like that sounds like the reproductive years when you stay home.
That's a great point. It could be. Yeah, I think that's a perfect
if you can't
possibility.
Home, you just have to quit the job.
Yeah, no, that
And this for policies. Okay.
makes perfect sense.
So one clarification question. So I wonder, what if you compare the travel patterns of teleworkers on non-commuting days? It seems like you identify these people based on their maybe monthly or so kind of teleworking frequencies, so passive and primary up to primary, but it doesn't mean that on that survey day, they didn't commute to the workplace. Some of them did commute and some others didn't. So I wonder if you compare only non-commuting teleworkers on their non-commuting day, and then the pattern might be a little different. So did you have a chance to do that?
So this is the difference between primary and ancillary. So both primary and ancillary, they reported that they worked more than one day from home in the past month. And on the day of the survey, if they did not telework, we classified them as ancillary. If they did work, we classified them as primary.
Okay, then home-based work trips for them would be on that day, would be not for their usual workplace, but somewhere else.
Correct.
Okay.
Yes.
Do you have a maybe thought on which days did the, let's say, primary and ancillary choose to telework? So I'm thinking some people start the pre-can by Wednesday and telework from home from then compared to other categories.
So that's a great question. NHTS doesn't ask that question. So NHTS asks you about your trips in the day before and nothing else. So we don't capture a week of travel.
To clarify, this is Monday through Friday. We're not looking at their patterns on Saturday and Sunday.
So this is during the whole week. So the survey happens on a random day in the week, and on this random day, they report the trips that they did the week before. Yes?
Did you check for spatial variation? Spatial variation in the results besides rural and urban?
Yes. So all of our figures, there's one for urban and one for rural. All
Yeah, but I mean, is spatial variation in urban areas like different places in a city or something like that?
So this is national data. So
I mean, like if you compare different cities or regions.
no, because of the sample size.
Okay.
So only 25% of our working population. So NHS is around 50,000 households that we survey every 7 to 8 years. So this entire data set is around 50,000 covering the entire nation. 50,000 households, around 132,000 people. So out of this 132,000 people, the workers are about 60% or somewhere there. So, and then because there's lots of students, so out of this 130,000, you end up with 50 or 60,000 workers. Out of those, only 25% are doing some form of telework. So and that's why going to a specific state or city, your data becomes very scarce. Great question. Yes.
So there is one comment from the chat box, so let me read it loudly. So from Taylor, she said, curious as to whether the change in trip distribution and length is a product of car dependence of the American urban planning and lack of long-distance alternatives other than air travel. So telecommuting increases flexibility for people who are telecommuting and also use their time flexibly. However, there is no real non-private auto alternatives in this case. So maybe people had to use their cars when they are making trips on, while telecommuting or not commuting. On days they are not commuting. So she's she's speculating that might be a reason why we see more EMP on telecommuters.
I absolutely agree, but still reinforces, so doesn't change the fact that telecommuting increases VMT. So
yeah, so there is a result, and she is speculating this might be one reason, one factor.
Could be.
Yeah.
I think that's something we can certainly explore. But could be, but does not change our primary objective.
Yeah, right. Outcome, try to understand why we see this outcome. And one kind of follow-up question or comment was that from Taylor was that, did you check walk score or kind of access to public transit, a kind of alternative mode, kind of feasibility around their home location, for example?
NHS does not give you the location of where things are happening.
You mean public version?
Second. So NHS tells you this person lives in this state. Okay. You don't know where they live in that state, so you can't come up with knowledge about the infrastructure around where they live.
Yeah. Any more questions or comments?
All right, these are great questions. Yes.
I know the data I think stops at 2020 and the research sort of ended, but does the survey also have data on how many people switch back from teleworking to other categories after maybe a lag period of the pandemic subsiding post 2020? And is that something you're looking at?
So this data is 2017.
Okay.
So NHS used to happen once every 6.7 years.
Okay.
Now it's happening annually, but in a different format. So 2017, this was the case. 2009, this was also the case.
And do they collect data on how many people switch categories?
No, so NHS is not a longitudinal data set, it's not the kind of data set. So it's 50,000 random people every time.
Now, by the way, to respond to your question, ITES, Davis, and 3R, including 3R and other research groups, have been collecting data during the pandemic, and we have some statistics about that switching population. So if you want to know more, let's discuss later.
All right, lots of really great questions. All right, ready for the second part of the study? All right, so FHWA, so we're working with the FHWA. The objective is to see what are the emerging mobility trends that are happening in our time and how are they going to affect our national transportation system performances. So that's the objective of this project, is identify emerging trends, and how are these emerging trends going to affect the future of our mobility in the nation. So one of these trends is obviously telecommuting. So telecommuting is happening, especially after COVID. So how is this going to affect our national system performance? And one of the metrics that we chose for the national system performance is VMT. So in this study, we have models about the relationship between telework and VMT. So the objective of this study is, the tasks are 5 main tasks. First task is identify and analyze what are the emerging trends that are affecting our transportation behavior. Develop a database to support these trend analysis and modeling. Build models to find the relationship between the trends and national performance, like VMT. Conduct some policy questions and analyses, and then validate all of our studies by national experts. So research question 1, this is the one that I'm going to focus on with you today. It is, what is the quantitative relationship between identified mobility trends, such as telework, and transportation system performance measures, such as VMT, mathematically. So the first step in this work is we identified 24 national trends, or 24 emerging trends that are affecting our travel behavior. So we classified these 24 trends into 5 classes. Some that are relevant to the traveler, some are relevant to the vehicle, some relevant to the infrastructure, to the trip, and to the environment. So examples of trends in the traveler. So what's happening to the population, what's happening to our socioeconomics, what's happening to employment, what's happening to public attitudes. With the vehicle, what's happening with vehicle ownership, with electric vehicle ownership, with public electric vehicle fleet, with shared use mobility, with on-demand services, with vehicle automation. In terms of infrastructure, what are the trends that are happening with highway infrastructure? Are we building more highways at a faster pace, at the same pace? Are we building shared HOV lanes or hot lanes? How's this trend happening? What's happening with transit service? Are we providing more transit? What's happening with active transportation infrastructure? What's happening with road band? What's happening with electric vehicle charging infrastructure? So that's all part of the infrastructure. With respect to the trip characteristics, what's happening to trip purpose, what's happening to modal share, with telework and with e-commerce. And last, what's happening to the environment, what's happening to population density, to the cost of travel, to access to transportation services, to transportation funding. So these are 24 trends, and we were interested in what's the relationship between each one of those trends and national VMT, national GHG, and national transit mode share. This clear, the objective of the work? All right, the objective, we wanted everything to be quantitative. So the first task is we needed to come up with quantitative measures for each one of these 24 trends. And these quantitative measures have to satisfy 3 criteria. Because we're interested in trends. We're interested in how this is developing over time. So every indicator, which is the X that reflects one of these trends, has to be measured over the span of 20 years, from the year 2000 to the year 2020, has to be measured annually, and has to be measured at the county level. So our objective is we wanted to get each one of these, what's happening to the population over the span of 20 years for every county in the country. Whether it's electric vehicle ownership, we wanted to know what is electric vehicle ownership in every county over 20 years. So this was our data. So building the data set was a huge effort, because we had to find data, numerical data covering 20 years for every county in the US. Measured annually. So NHTS is not a data set that we could use because it's measured every 6.7 years.
So can I ask, which data did you use then?
Different data sets.
Okay.
So this project is 5 years. We just finished the 2nd year and we're starting the 3rd year right now. And every year we add to the model, we add 5 indicators. So at the end of the 2nd year, we have 10 indicators that we have in our model. Telework is one of them. So this is the trend for population. Our indicator is population size. For socioeconomic status, the indicator, which is the quantitative measure of socioeconomic, is gross domestic product. So we know the GDP of every county every year over the span of 20 years. Population size, we know the population in every county over the span of 20 years every year. In terms of employment, we have the unemployment rate in every county over 20 years, every year. For highway infrastructure, we know exactly how many highway lane miles in every county, every year, for 20 years. So this is how we pick these indicators. So some of these indicators are not perfect measurements of this trend, but it is the one thing that we could find that satisfies our quantitative requirements. That we can observe it at every county, every year for 20 years. For example, one of them is on-demand services. On-demand services is Ubers and Lyft, TNCs. There is no data that exists in this whole country that tells us how many TNCs, or how many TNC vehicles, or how many TNC riders in every county over the span of 20 years. Annually, there's no such data set. You can't even find this data set for the last 2 years. You can find them maybe for San Francisco, or maybe for Chicago, but you cannot find them in every county in the whole country every year for 20 years. However, so the measure that we used, which actually exists for 20 years in every county, is there. So every person has to submit their taxes, every business, every income has to submit their taxes, and TNC drivers, they have to submit their taxes indicating how much they earned from driving the Ubers and Lyfts or taxis every year for 20 years. So this is the indicator that we use for TNC that reflects the development or the trend of on-demand services in every county nationally. Yes?
Is that, like, I mean, I'm not sure like how they report it, but do they report it like as a global thing of non-employee income, or like does it specify that it's non-employee income from driving?
From driving.
It doesn't specify.
It does specify that. So because they have their own work classification, then you can find exactly how much they earned in every business, which is as an Uber driver, your own business, they have to report this. So that's how we came with an indicator that helps us capture the development of on-demand services across the nation, in every county, every year for 20 years.
Could there be like an underreporting?
There could be an underreporting, but some data is better than no data.
Yes.
So naturally, there are some errors, but hopefully these errors are homogeneous, or they've not changed much or random throughout the 20 years in the counties. So hopefully they will cancel each other and they can give us an actual indication. For telework, so we use the ACS. Now ACS, the American Community Survey, so they survey 3 million people every year. So we survey 1% of the population every year. And one of the questions that they ask is, what is your primary mode to go to work? So they ask only about the work trip, and they don't ask details. They just ask what is your primary mode of traveling to work. And one of the options, so there's car alone, carpool, motorcycle, bicycle, so there's all of them. And one of the modes is telework. And the ACS is 3 million people, so that's a very large data set annually. And it covers every county, every year, and the question has been consistent for 20 years. So this is the question that we used to reflect telework. All right, so everybody following what the data set is? Yes.
I go back to the TNC driver revenue. What's the data set for that?
I can't remember the exact name, but it's I can send it to you. So if you send me an email, I can tell you. But it's
Is it public?
yes, all of our data sets are public. So that was another criteria
At the county level?
at the county level. So one of our criteria was we wanted all the data sets to be public. Actually, that's one of the federal highways criteria. So they asked us any data you use has to be publicly available. All right. The VMT, so there is the national VMT by county. There was a limitation of the VMT. So the VMT counties and states report their VMT to the FHWA every year by highway class. So they classify the highways into rural, freeway, rural multi-lane highway, urban freeway, urban multi-lane highway, and then regional connector, arterial, and so on. So there is a classification. Now, over the span of the 20 years, not all counties across the country reported the same highway classes. So we couldn't, what we modeled was not national VMT on all roads in every county. We felt there was consistency with how counties were reporting this. So what we modeled at the end was rural, freeway, and multi-lane highway miles. So our VMT, our national VMT, by county every year, is limited by highway classes. So we're only doing rural, freeway, and multi-lane highway. All right, so key activities, now we're ready for models. So we got our data, we have all the X's, we have all the Y's, we have the whole nation by county every year for 20 years, we're ready to start modeling. So our key activities is we identified all the indicators for all the data sets, all the trends. We cleaned all the data, so lots of inconsistency with the data that needed some cleaning. So we cleaned all the data. At the end, we had this huge table, 4,000 counties across the country. Every year for 20 years, every county has all these X's and these 3 Y's. And then we, part of the project is we're giving this data to the FHWA, and the FHWA wants to have this data publicly available for everyone. So we're helping them create a database where this data can be accessed by anyone. Some challenges, county data is not always complete or consistently reported. So I mentioned the VMT. Certain mobility trends do not have consistent sources of county level data over time, and that's why we need to come up with surrogate measures. Challenge 3, certain mobility trends data exists at MSA or UZA level. So sometimes you can't find the data at the county level, but you can find it at the MSA level, which requires some assumptions, and primarily transit usage data. So transit usage data, which comes from the National Transit Database, NTD, they do not report their transit use by county. They report it by UZA and MSA because this is how cities operate. So for example, the BART works in many counties, and they cannot specify this is the number of users in each one of those counties. So they report the BART usage by the San Francisco area, San Francisco metro area, which is a UZA. So now to divide this information by county, we have to make some assumptions. So dividing by population and so on. So at the end, this is the data that we have. So these are our 10 trends. These are our 10 indicators. This is the data source. So here's your answer about the on-demand, county revenue. So the data is NAICS. Census non-employer statistics. That's the data set. And telework comes from American Community Survey. This is when does the data start? So our objective was to have 20 years. We ended up having 15 years because some data did not start until 2005. So at the end for VMT, we had 60,000 observations. For greenhouse gas emissions, we had 60,000 observations because the data set is reported by the EPA once every 3 years. So our data is divided by 3. And for the National Transit Database, our data is 44,000. Okay, so the objective now is I have all these inputs, all these X's. I have this Y VMT. What's the relationship between both? Now, what do you think are some of the challenges to model this data? So what model would you use and why? For example, do you see a challenge in using population and GDP and unemployment rates in the same data set, in the same set of X's? So non-normal distribution, most of our models require normal distribution. Our data, most of it is not normally distributed, so that's the first problem. So we cannot use linear regression. There's a large group of models that we cannot use because the data is non-linearly distributed. There's very high correlations. So there's a huge correlation between population and GDP and unemployment rates. And this is called multicollinearity. So this significantly affects what models you can use. So multicollinearity is a big challenge. Data in 1 year, so VMT in a county in 1 year is related to the VMT in the county next year, is related to the VMT in the county following year, so that's called autocorrelation. So if you do not model autocorrelation, then your models are giving you wrong results. So we had a bunch of very challenging methods that we needed to employ to develop models that are actually meaningful. So for non-normal distribution, we log transform all of our data. So our data are log transformed instead of working with the actual data. Now there is a downside for log transformation, but it's a small downside, so it does not affect the validity of our results.
Can you repeat that?
So our data is not normally distributed. So we log transformed our data, and the log transformed data is normally distributed. But log transforming your data underestimates your predictions. So log transformation is inherently characterized by under prediction. So this is one of the known drawbacks of log transformation. But you can fix this under prediction by just quantifying what under prediction is and adding a delta to all your predictions so that everything is fixed now. Of course. For autocorrelation, so we ran autocorrelation tests in our data, and our data was not autocorrelated, so this did not require fixing. The last challenge is multilinearity. And for multilinearity, we use lasso regression models, and lasso regression models are designed to handle multilinearity. Now, to explain to you, if your data is multilinear, if your axes are correlated, that's what multilinearity means. This means if you're modeling, if you have in one data 2 axes, let's say I want to model what are the chances of someone getting an A. So I'll model what are the chances of getting an A. And in this model, I put how their GPA score, and I also put how many hours they study per day. Now there's probably a very strong correlation between GPA and how many hours you study per day. So if I put these 2 axes, then when you build your regression model, one is always going to be positive and the other is going to be negative, which is going to make you think that the higher the GPA is, the higher the chance of you getting an A, but you should study less hours per day. Doesn't make sense. But this is why you cannot use linear regression models when your data is, when you have multilinearity. But if you model them using lasso, both of them will be positive because lasso is designed to handle this multilinearity.
It's called lasso, the model you chose?
Yes, so lasso stands for, so this is how we handled this. Specific, so lasso regression. I think in one of the models, in one of the slides, we spelled what lasso stands for. Okay, we don't.
You're looking at things.
Yeah, but you'll find it. It's a very popular model. Yes.
And then I wanted to ask, what did you do here to address the autocorrelation?
We tested autocorrelation statistically, and it wasn't an issue.
Okay.
Yes.
With the lasso regression, maybe I'm confusing this with the ridge, but
it is the same as the ridge.
It penalizes some coefficients that may not set them all the way to 0. So do you have like a graph of which coefficients and variables were penalized the most?
Yes. So actually, we tried with lasso and with ridge and with elastic net. So we tried with all 3.
Okay.
And all 3 were the same. So we ended up working with lasso because it required the least number of assumptions.
And which variables were the least penalized in the axis side?
I don't remember. But all the ones that were removed are not included in the final model. So we assume that they were not significant. Okay, so this is now what everything I mentioned was year 2 where we did the county data model. But in the year 1, we did everything at the national level. So instead of looking for county observations every year for 20 years, we looked for one measure nationally for every year for 20 years. So when we have one measure nationally every year for 20 years, so we only had 20 observations, because the whole country we had one observation every year, and we were trying to model 7 X's. So your data is 20 observations, you're trying to estimate 7 coefficients, so that's a very, very weak model. But that's why we went to county, because now we had 60,000 observations, we're trying to estimate 10 coefficients. So your model is much more powerful. But the one thing that you should notice here, when we did it at the national level, telework was the #1 most significant model on how much it impacts VMT in a positive fashion. So telework, when we modeled the data nationally, was consistently associated with increased VMT. The more people that telework, the higher our national VMT. But when we modeled at the county level, telework is now negative and has a small impact. So now there's a question. So why would when we investigate how teleworkers are behaving on a daily pattern, we see strong evidence that they're making more VMT every year. But how come when we do aggregate analysis at the national level, we find at the national level, so I'm not going to mention this national model because our data size, 20 observations, really limits your ability to come up with confidence about your estimated coefficients. But still, it's an indication that it was actually number one. Whatever model we ran, if I dropped all these x's and I modeled with only telework, it's positive. So it was consistently positive and consistently have a very high impact. So while year one model, we should not really place that much attention to it because it's only 20 observations. It is something that still grabs one attention that it goes along with our observations at the personal level. But now when it comes at the county level, it's negative. And it was consistently negative. So I started thinking, okay, so and it's now more in line with our intuition. So the question is, so what is telework, bad or good? Yes?
It's because like the sizes of the counties are very different. Like if you look at it at a county level, like sometimes it's up or down to the national level. Your zoning troubles, right? Does that have anything to do with the size of the counties?
Yes, and to fix this was another challenge in our data, and I forgot to mention it. So if you have, it's called repeated observations. Whenever you're building a model, you always assume that your observations are independent. Now, but because we have repeated observations, because I have 20 observations for San Francisco County, I have 20 observations for Fresno County, and I have 20 observations for every county, then your observations are not independent. You're measuring VMT for the same people, because people live in San Francisco do not change every year for 20 years. So you have 20 repeated observations for the same population. So this violates the assumption of independence, that your data observations are independent. And to fix this, we developed mixed effects model, which means for every county, we had a coefficient that captures how every county is different from every other county. So this independence observation is no longer an issue because we developed mixed effects models. But every county has its own coefficient. Interesting. All right, so now we go back to this question. So, telework, good or bad? How can you make sense of this difference? Because the truth is just only one truth, and we're trying to find what this truth is. We try to find the truth in 3 different ways. 2 of them aligned, but one of them is really not one that we can place much faith on. So really, we have 1.5 methods that say bad, and 1 method that has a much larger data set that says good. Yes?
Income, like the purchasing power of the county of New York versus 3 other counties that are lower income. So by volume, you get less EMT because there are many countries with less or shorter trips, and a few when you aggregate in a pool that add up to more VMT.
Are you saying that because San Francisco is measured with the same, has 20 observations, just like Bakersfield has 20 observations, but Bakersfield is much smaller than San Francisco? But at the end
of with the ratio of yes, the VMTs and the income.
But San Francisco has its own high VMT and its own coefficient, and Bakersfield has its own small VMT because it has less population and whatever telework is. So at the end of the day, we're trying to model the relationship between VMT and telework, and we're taking into account that San Francisco is very different. That's why it has its own coefficient. So that's the mixed effects model. That is the purpose of the mixed effect model.
That you don't mix them. This would be an answer.
So one question. So how many counties do you have per year?
4,000.
So including urban, suburban, rural counties as well. So my theory would be that for a county model, you happen to include a lot of rural counties. I guess number of rural counties way more than urban counties and suburban counties, and somehow they had no teleworking. I guess quite small personal teleworking, while on average they drive more because places are low density and scattered away. So I wonder this telework rate is actually capturing the kind of trade behavior differences between urban counties and rural counties. So there might be one theory.
But urban counties have their own population, is capturing the differences in population, and they have their own GDP, and the whole number of lane miles, and they have, so all these other factors are capturing these differences. And they also have their own coefficient. So at the end of the day, the coefficient of telework is capturing only as telework increases in a county, does its VMT increase accordingly or not?
So you, really, okay. But you didn't capture density.
Well, yes, density turned out to be
Okay.
But
most of these areas, teleworking rate is 0, right? Rural counties.
No, not zero. Because if there's one person teleworking in the whole county, it's still a percentage.
Non-zero.
Yes.
Got it.
However, remember, there is one important assumption about the VMT that we modeled. I told you VMT was inconsistent between over the counties over the 20 years. And at the end of the day, with the VMT that we're modeling is rural, freeway, and highway VMT. So the question now is, what do you think is the relationship between telework and rural VMT? Because that is what we modeled. Because the data was inconsistent. Yes?
Could be a locational factor. You're further away from your location, work location of the city center, so drive more, and that's the negative side.
Could be. All right, so I'm gonna tell you at the end what's our final conclusions, because I know that this has been too long or taking too long, and I can feel your energy dropping. All right, so this is the key findings of this study, and then I'm gonna integrate our guesses, our best guesses about both studies. So, the county VMT is most sensitive to unemployment rate. So this is a sensitivity analysis. If unemployment rate increased by 1%, what's our expected change in national VMT? So, and 1% means going from 4% unemployment to 5% unemployment. So we think unemployment is the most significant factor, and it's as 1% change in unemployment is accompanied by a 1% change in VMT. Number 2 is population. 1% change in population increases VMT by 60%, 0.6%. Telework is number 3. As telework increases, rural VMT increases by 0.5%. Highway lane miles is 4th, positive. GDP is positive. Electric vehicle charging stations was negative. Does this make sense? The more electric vehicle charging stations we have in the country, the less the VMT. Why?
Would have to drive less to find a charging station.
So the one factor is you have to drive less to find a charging station. Another factor. Now, electric vehicle charging stations is the indicator we used as a surrogate measure to electric vehicle ownership. Because we couldn't find electric vehicle ownership for 20 years every county, but we could find the number of electric vehicle chargers in every county over 20 years. So this is our surrogate for electric vehicle ownership. So we assume that as more people have electric vehicles, the more chargers we have. Yes?
This is a correlation. So you're saying the more EV charging stations, less EMT?
Yeah, there is a correlation. And on top of that, actually,
it's an association. Yes.
What is the last data year here? 2020?
So before 2019.
2019.
Yeah, so we don't have COVID.
Yeah, I assume that EV charging stations, more of charging stations were still in urban or relatively dense part of the countries, either urban or rural counties. So that is still kind of capturing some of the density effects where people live in dense areas. They tend to drive less, in terms of distance.
That should be controlled by the county coefficients because it's the fixed effects model.
Yes. So can you find why the more electric vehicles we have, the less VMT? Yes.
I would say we have to look, this is 2019. What is the average electric vehicle range for that period of time? It's quite limited.
Exactly. So remember, this is rural miles, rural VMT. This is not all VMT. So we think it's because, first, it's 2 reasons. We think it's self-selection bias. So people who drive less are the ones who are or buying electric vehicles because they're not concerned about range thresholds. And plus, people who own both vehicles, they are the ones who will use the electric vehicles for the shorter trips. Because again, because of range and anxiety. So we think this makes sense, and at the end of the day, it's really very small. So it's 0.0067%. Quarterly revenue. So this is e-shopping. So the more e-shopping, the higher the increase in VMT. We think this makes sense as well, but it's also very small. TNC is an interesting one. So more TNC, the more VMT. There have been several studies who indicated the same thing, that TNC is taking lots of transit users from walking and biking. So it makes sense that the more TNC, the higher the VMT, but still it's very small. This one is one that that is probably because of the issue of transferring UZA data into county data. This one is saying the more people are using transit, the more VMT. Now this one doesn't make sense for us at all, but we think it's an issue with the conversion of UZA data to county level data. And last is population density, and this was not significant. All right, so conclusion. So we think the first study, Patrick's study, we think there could be a self-selection bias. We think, so Patrick's study has found that the more people telework, the more they have VMT. But the question is, are they traveling more because they are working from home, or do they choose the jobs that allow them to work from home because they want to travel more? So there could be a self-selection bias. It could be teleworkers are traveling more because they, as individuals, they choose these jobs because they know that they need more trips per day. So the self-selection bias is a possible reason why the relationship that we observed in Patrick's study exists. So we need to follow up on this, and we need to test against self-selection bias. Another reason is it could be telecommute behavior. We should investigate telecommute behavior by season. And so one of you mentioned that household structure could explain why teleworkers are doing more or less trips per day. It's the household structure is one aspect, but the other aspect is by season. So you want to test, all right, is it really the schools that are making the difference? If we investigate how telework behavior during the summer compares to non-telework behavior during the summer, where kids are no longer an issue, then does this relationship still hold? So these are two extensions that we want to do following Patrick's study. In terms of the FHWA study, so we want to use additional models such as decision trees. We want to do change point analyses. Perhaps telework had some positive effect in some period of time, and now later on it has a negative effect, or perhaps it was negative, now it's positive. So we want to investigate, does this coefficient of telework change over time, and by how much? Causality. So all of the models that we saw modeled, the last model, linear regression models, these are models of association. They do not indicate what's causing what. And now we model VMT by rural freeway. So perhaps if we model VMT on all roads, the relationship would be different because urban behavior is very different. People who use the freeways are very different than people who use these roads. The vehicle class, VMT that we model is both trucks and cars. So if we really want to deduce information about individual traveler, then we should use VMT by cars only, not trucks. We want to model PMT, and then we're going to model state level data. We want to model state level data because at the state level, we have the classification of highways. This inconsistency over the 20 years does not exist. So we can actually see VMT, the total VMT of both urban and rural, or we can split them. And last, we want to model by NHTS year. So we want to find a way to integrate information from National Household Travel Survey, which means instead of having data for 20 years, we will have data for 2 years only, 2001, 2008, and 2017. And this is our last conclusions. Any last comments before I thank you?
Any questions, comments? Yeah. No problem. Yeah. Let's give a big applause.